Hello, Keith Rucker here at VintageMachinery.org. Guys, today is a very happy day for me because I think that we have finished this 10EE lathe. I think it is back in service and is back ready to go. So a little bit of a recap. This lathe was actually given to me by a viewer, Willie Bemis, up in New York. He bought it, I think, at an auction or sale, I can't remember, but when he got it into his shop and realized that there were some electrical issues going on with this thing. Basically, they had ripped out all the original electrical drive components. They had put in a Frankenstein system in this that just didn't work really at all, or maybe not at all, but didn't work well. And when he started looking at what it's going to take to get into it and fix it, it was just way beyond his capabilities. And he just decided that he was going to cut his losses, and he offered the lathe to me, and I took it. And I probably really didn't realize what I was getting into, because it started us down a journey of totally redoing this drive. And if you guys watch the channel, you've kind of seen this process. I had a viewer reach out to me, John, who lives up in Minneapolis area. John has asked that I don't really give out all his information, but he retired electronics person, and he said, you know what, I think I can come up with a new system. And he went through, he did a tremendous amount of work digging through old literature, finding the original specs on a lot of this electronic stuff in here, and basically coming up with a whole new electrical system that was brand spanking new. And this system is complicated, and that's all I'm going to say. If you can go back and watch some of the videos on it, I don't even fully understand it all myself, but we basically came up with a system that works. And over the last couple of years, yes, years, I've gone through this lathe. We have built a new drive system. Through trial and error, we have got it to where it works, and it works well. I went ahead and did a restoration on the machine itself. You know, we stripped off the paint, re-cleaned it, took off the carriage and everything, did some scraping, kind of tuned things up a little bit, put it back together. In truth, the machine was not in very bad shape. Probably didn't require some of the stuff that I did to it, but while we had it apart, just went ahead and did it. Just because it was easier. It just made sense to me to just go ahead and do some of the work that we did. So I went ahead and did all that. And literally just today, I got off I won't say my last phone call with John, but you know, we basically kind of went through and did some final testing, looking at it actually in operation, making cuts, and it was fine. We thought we were going to have to make a few little tweaks to some of the settings on some of the things, but in the end, it was working great. So we just decided to leave well enough alone. So this lathe, again, as far as I'm concerned, it is restored and it is ready to use, and we're ready to start utilizing it in the shop. I thought I would like to just kind of show you the lathe finished up here. I thought that we would go over here and actually do some cuts on here. There are a few little things that I have made some cuts under load. We've made 100 thousandths cut with this thing, and basically it's a fairly small lathe, 10-inch lathe. The tooling's kind of small. I was making 100 thousandths cut, well, a 50 thousandths cut, 100 thousandths off the total diameter, and basically got to the point where I was more or less maxing out what my tooling was capable of doing, because it's small tooling, and we weren't even, I mean, the lathe wasn't even operating under stress. I mean, it was just plowing it off. So I thought I would kind of show some of this. I think I'm going to do a little test on it where we'll turn something and check the diameters. One thing that I haven't done yet on this is do some threading. I thought maybe we'll do some threading and just kind of check it out, see how it goes. I'm honestly kind of learning this machine. It's the controls on it and everything are a little bit different and from what I'm used to. So, you know, it's nothing crazy, but you know, I'm still kind of figuring out what levers to turn and what have you. One thing that's I've noticed, and I've talked about this before, you know, you get used to running a machine and you just instinctively reach for certain knobs and things. And one of the things on this lathe is the forward and reverse to turn the spindle on is this little drum switch right here. It's not powered up right now, but you move it forward and that makes the chuck turn, you know, in the forward mode, or you move it back and it makes it move reverse. Basically got a little drum switch in there that does that. You know, on my other Monarch lathe, there's a handle down here on the carriage that you lift up to engage the spindle and disengage it. And when I was over here making my test cuts, I would be getting it into my cut and I'd be reaching down for the handle and it's like, oh, no, the handle's over here. So something to get used to. I've talked enough. Let's get in here and make some chips and see how this machine works. So just got a piece of steel chucked up here. I'm currently got a 6-jaw chuck. This actually is a chuck that came with a different 10EE lathe that I picked up. I got another one that I still need to restore. And it actually is in excellent shape, at least from what I can tell. The biggest drawback that I see with this chuck is that it's long. I mean, how long is that? So we're looking at, you know, 5.5 inches from the back to the front. And on this lathe bed, I mean, I've got a pretty short bed on here. This lathe is for doing smaller stuff, but you know, a regular 3-jaw chuck normally isn't as wide as this. I could probably pick up an inch or two of length by going with a chuck that's not quite as big as this. And I might try to find a little bit different chuck. Also, this chuck here it's what, a 7-inch chuck, 6.5-inch chuck, something like that in diameter, maybe 6 inches. I can't get the tape measure all the way in there, but might try to find one that's even a little bit larger diameter, just for a little bit more capacity. But this is a very nice chuck, and it actually is one that you can, a true adjust they call it. You can move the back here and fine tune it kind of like you would a 4-jaw chuck to get your chuck running perfectly true. So it's a nice chuck, but yeah, wouldn't mind picking up a good little chuck for this 3-jaw chuck that not quite as deep. Anyway, again, I digress. I'm going to power it on, hit the main power switch down there. Now whenever I turn to the drum switch, let me show you that. So the drum switch, again, you move it forward, and it turns on. Go back to middle to stop, and then that's reverse. So it's got basically it will stop the chuck pretty quick. It's not instantaneous, but it will stop the chuck pretty quick whenever you quit running it. It is all variable speed. There's a knob down here that you can electrically change the speed on it. Right now I'm running at about 1,000 RPMs. All right, let's just come in here. I've got a cutter on here and we're just gonna make a cut and see how she cuts. We'll come in, we'll just touch off on that. And I'm gonna do a 50 thousandths. This is a 50 thousandths total, so 25 thousandths depth of cut, but you're moving it on both sides. We'll engage the spindle, and it just peels the metal right off, just like it's supposed to. I've just got a piece of mystery metal in there, don't even know what grade that is. And I just grabbed a tool here that I'm not even sure how sharp that insert is, but it's doing a good job. So you can see just peeling it right off. Let's just go ahead and let that cut all the way through, and we'll try a little bit heavier cut and see how it cuts. I want to do a 75 thousandths cut. Now we're not going to be making a full cut till we get down here a little bit deeper, but I think that's about a 25 thousandths cut there. And we'll let that cut down. Let's get down to the heavier cut where it engages, and you can see a 75 thousandths total diameter removal. All right, here we're going into the heavier cut. it's removing the metal just fine. The machine's not even under a load. But you can kind of see where my cutter is struggling a little bit, but the machine is not. All right, cleaned up. I want to do 100 thousandths total now. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 on the dial. And again, the lathe's just not even under any load at all. It doesn't even know it's cutting, which is a good sign. I'm making a pretty nasty chip though. I'm not going to make this go the whole way just because I'm going to make another bird's nest. So we'll just stop right there. I'm going to turn an area down to 3/4 of an inch, and we're going to do some threading. So let me go ahead and get that done real quick, and we'll go from there. So I'm going to cut 3/4 10 threads, and to do that I need to change my thread dial here. So the 10 is right here, and the way we do this is you loosen that up, and now I can turn this little selector, and I'm going to line that up with the one on 10. And then I need to have my knobs in the A and the D positions, which are these right here. So this goes to A, and then that one there goes to D. So AD 10, and lock that in place, and that should be set on 10 threads per inch. And then up here I need to come out of feed and over into right hand threads, and I gotta remember how to make this adjustment. There it goes. So, and then right hand threads. So now when I turn this on, it should be turning that top rod. Oh, I got to engage it right here. All right, 10 threads per inch. I'm also going to slow my speed down. Right now we're at about 1,000 RPMs. There's a knob right here that controls the variable speed. And we're just going to bring it on down a pretty good ways. In fact, we could even go into back gears for this. And I'll tell you what, I think that's what I'm going to do. I think we're going to go into back gears just because. So there's 2 speed ranges on this. You got back gears and regular, just direct drive, and then you change that right here. I'm just going to move this up to back gear. Now that will greatly slow down. It's mechanically going through a gear back there to change the speeds, but that will slow this down, and we'll get down to about something slower for threading purposes here. All right. There's a belt for feeds, and then there's a gear for threads. The belt is designed where it's in the back here. That's what drives your feed rod down here. It drives both of them, but in the belt it can slip. In the gears it's directly geared to the headstock, and that way it will not slip and you can't lose your thread place. So I think we are now ready to go do some threading. So let's go up here and check that out. Another thing, just FYI, there's a lever on the apron that makes it go either right or left. When you're threading, it needs to be in the center neutral position, and that will just prevent you from accidentally turning on your feeds or anything, although that rod's not turning, but that will allow you to, there's an interlock in there that prevents the half nuts from engaging unless it's in that neutral position. So we're set up. I'm going to come in here. We're going to just kind of chamfer that leading edge. I'm going to set my stop here on the cross slide. There's a stop here that goes to a hard stop. and that comes to 0 every time. And then we'll feed in. I got my compound set to 29.5 degrees. I'm going to touch off, and let me get some oil. Some of these 10EEs have an electronic lead screw reverser for doing threading. This one does not, so we're just going to be doing more conventional type threading. So, all right, let's just making sure I got everything where it needs to be. Let's go ahead and engage, and we'll cut some threads. Oh, didn't like the way that clicked in. There we go. Just making a light pass here. And I'm going to get out here to the end, and we'll disengage. Come back to the beginning. I go back to 0. Again, I got the stop, which is a nice feature on these Monarchs. Take a little bit heavier cut this time. Let our thread dial come around till it comes to a number. We'll let it make another cut. All right, let's, I think I'm gonna speed it up just a little bit. And we'll feed in another little bit on it. Oops. And here we go. Another pass. About 20 thousandths on my end feed right now. We'll probably go to a little bit lighter cut on this next one. About 15. So let's do 15 thousandths in feed. Another 15. Go to 10 on my end feed. Another 10. Getting close to a sharp point on the top of those threads, which means I'm getting close to my depth. There we go. I'm gonna make another pass, maybe 2, and we'll do a test fit with a nut. Need a little bit more. Put a little more oil on here too. Do a spring pass here, and we'll check it. All right. And there we go. Threading. Works fine. Nice thread job. All right, I think what I want to do is put a longer piece of metal in here and turn a long piece and just check it to make sure that we're not getting any kind of taper in the cut. If so, we might have to make an adjustment to our tailstock. Although we did check the tailstock with an indicator, it should be in pretty good shape. We might need to make a fine adjustment there. Let me find something to do that test with. So I got a longer piece of metal in here. This is, I mean, it could go a little bit longer, but I'm within my tailstock of being probably 1.25 inches from being off the end of the table. So, you know, this is getting to be kind of the length of what I can turn on this lathe, at least with this chuck. I'm just gonna clean this up. I do note that my chuck has got some run out in it. I'm just gonna turn it right now. I'm not worried about trying to adjust this chuck. This is an adjustable chuck. I can fix that, but I'm more interested right now in just checking this for taper. So we'll just turn the run out and go. I got a little key on this end, but we'll just, again, we can measure across it there. It'll be fine. I think we are ready to go. Let me see what we got here. So I'm running again about 1,000 RPM. My feed rate, let's see. We'll try that. That may be a little bit fast. If it is, I'll slow it down some. But for roughing, we'll probably just roll with it. I'm just going to do about a 50 thousandths. Got an interrupted cut right now. Again, we're kind of cutting that run out. But for my tests that I'm doing, I just need to get it cleaned up, clean metal, and we'll be fine. Got mystery metal in here. I don't know what grade this is, just something that came out of the scrap pile. But it'll be fine for the tests that we're doing. All right, we'll just stop about right there. See what kind of finish I'm getting. Yeah, it's not bad. My feed rate is just a little bit on the coarse side, but nothing we can't deal with. Getting a little chatter. Let's see what we can do here. Something's not right. So that is better, but I'm still getting some chatter. Maybe I'm gonna just speeding things up, see if I can find a speed that works a little better. We're up about 1,600 RPM right now. Still hear a little noise in there, but we'll make the cut and see what it looks like. All right, I'm not real happy with that finish, but I'm gonna do another 25, and then we'll probably come back with a lighter pass just to. Yeah, not happy with that finish. Let me change some inserts out here and see if I can find something that works a little better. I got a different cutter in here with a good sharp insert in it. I'm gonna take a light 10 thousandths pass. Yeah, I'm still getting some pretty nasty harmonics. I sped my feed up to about 2,000 RPM trying to find the sweet spot. about 2,500 RPMs. Sounds a little better. I can still tell there's some harmonics in there. I'm not sure what's going on. I'm wondering if there's maybe not something going on with the headstock bearings. I'm gonna have to do a little bit of digging into this, but I want to check this for alignment right now. So let me get this cut made and we'll see what we can do. So after playing with my speeds over there, I'm up around 2,500 RPMs, and I was taking a light cut. We got a pretty decent finish on there. I'm pretty happy with that. Still a little bit of vibration when we were first starting, but acceptable finish as we go. What I want to do now is check the diameter down through here and just make sure that we're making a straight cut. So I'm going to start at the end and we'll get a measurement, and we're just a little over 525. That's about 3/10,000ths. I'm going to go all the way down to the other end, and we're about 1,000ths under that. That's about 2/10,000ths, so about 1,000ths and 1/10 taper going down through here. And yeah, as you come down, actually that's running, it's just right here at the end, and it may have something to do with, you know, we got a little bit of chatter as we were starting. Once we got to about right in here, it quit. So that chatter may be the reason why that's doing, because that's reading about a 1/2 thou from where we started, and then down here we're dead nuts on. So all in all, I'm pretty happy with how parallel that is. Like I said, down here on the end where we had that little bit of vibration, that's the only place I see an issue. I'm going to have to do some research and figure out if there's something kind of adjustment I can make to try to address this vibration. If anybody's got any suggestions, feel free to leave a comment or reach out to me by email or whatever. Yeah, I'm not sure what's going on here, but all in all, I'm pretty happy with the alignment. Like I said, other than I think that the little bit of largeness down here on the end has more to do with the surface finish than it does with the actual measurement. From there to down here, I mean, we're reading about 3/10ths difference just looking at the micrometer. And if I run my hand across this, about right in here, I can start feeling it getting a little bit rougher. So I'm pretty sure that's where the problem is there. All right, yeah. Can't say that I'm 100% happy, but I'm about 90% happy right now. One other little thing I want to note just before we get out of here. When I put this back together, I didn't catch it at the time, but there's a little cover that fits up underneath here that just kind of keeps trash. When you pull the lead screw in, it opens up underneath there, and this little cover will slide back and forth in there. There's a little slot that goes over a screw to kind of keep it, or there's a pin in there that will keep it from coming out. And the story on this is, guys, is that after I put the lathe back together, I was cleaning up the shop, and over there by my parts washer, this was laying on the ground, on the floor. And I reached out and picked it up and said, "What is that?" I'm like, "Oh, I know what that is." And it was like a couple of days after I put this thing back together. And so to get this in here, I'm gonna have to take it back apart. I'm gonna do that off camera and get that back in there. But to my knowledge, that's the only thing that's really left to do. I did not have any leftover parts, unless there's more leftover parts laying around on the floor somewhere. I don't think there is. I think this just kind of slipped through the radar, but we'll get that taken care of. Well, all in all, I'm pretty happy with this. The results here, like I said, I'm got to figure out what's going on with a little bit of vibration up there. I have the suspicion that we might just need to tighten up something up here in the bearings in here. I'll be honest with you, I took the cover off and peeked in here, but I did not make any adjustments to anything inside the headstock, and was really hoping I wasn't going to have to. But yeah, there's a little bit of vibration, so I'm kind of wondering if that might be in there. I've never really gone into the headstock of one of these before, at least not with 10EE, so I'm a little bit, a little nervous about it, but yeah, it's not like I'll be the first person to ever do it. There's information on what all's involved. If you got any other suggestions or whatever, again, feel free to reach out to me and we'll see if we can get that one little issue taken care of. But with that, I think we're about done with this project, and looking forward to having another tool in the arsenal to be able to do some precision lathe work on, particularly on some smaller stuff. You know, when you're doing small work, it's better doing it on a small lathe. You can do small work on a bigger lathe, but it's just, you can get better precision typically on a smaller lathe, and these Monarch 10EEs were made for precision. So that's what I'm hoping that we'll have once we get this thing all totally wrapped up. So with that, that's a wrap. As always, guys, thanks for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. It helps out a lot. Hit that bell icon to get notifications when new videos are posted. Big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. All those are a really good way to help out, go the extra mile, and help make a little contribution to the cause here and help me justify, take the time to shoot these videos and bring them to you. Guys, with that, I'm going to get out of here. We'll catch you on the next video again. As always, thanks for watching.